Ceramics, specifically tiles. Tiles. A tile is a thin, often decorative ceramic that is generally used for flooring, walls, and roofs. Tiles are typically composed of clay, sand, feldspar, quartz, and water. What is a tile composed of? Clay, a natural, fine-grained, earthy material made from broken down rocks that become soft and plastic when wet, but hard when fired. The main ingredient of tiles. Fine grain. Clay particles are extremely small with flat, plate-like shapes that cause them to stick together and give clay a sticky characteristic when wet. Plasticity. When wet, the flat particles allow material to be easily molded and shaped. Hardening. When fired in a kiln, the high temperatures remove water and cause the material to permanently harden into a ceramic. Feldspar, a substance that lowers the melting temperature of glazes and bodies, allowing them to fuse at lower temperatures and saving energy. A mineral that acts as a fluxing agent, aiding in the other materials to soften, melt, and bond together during firing. Fluxing agent, a material, feldspar in tiles, that lowers the melting temperature of a mixture, making it possible to fire at lower temperatures and form a glassy, durable surface. During melting, flux melts and forms a molten, glassy liquid that fills the pores and spaces between the solid particles of the clay body. As the tile cools, vitrification occurs. The liquid solidifies, bonding the particles together into a strong, dense, and durable structure that is watertight and strong. Sand. The sand adds strength and stability to the tile, and quartz it's 93% composed of natural quartz and 7% resin, which enhances the strength and durability as well. Water is added to all these dry ingredients to form a pliable paste or slurry for molding. Mining. Clay is primarily mined through open pit mining. Solid rock is removed usually with excavators and scrapers. Once clay is exposed, it is removed by shovels, drag lines, and other front-end loaders. Processing. Milling occurs to the raw clay by either machining or particulate processing to reduce the raw ceramic into a fine powder. Machining is a process that uses computer-controlled automated machinery to cut and mold the tile shape. Particulate processing is a series of mechanical and chemical steps used to refine and prepare raw clay for manufacturing into ceramics. It's used to get the desired composition for the clay tiles. Processing. Clay is processed by mixing clay, sand, feldspar, quartz, and water, forming the clay into a shape by dry pressing or extrusion. Drying the tiles to remove the moisture and then firing them in a kiln to create a hard, durable product. Extrusion is the moist plastic clay mixture that is forced through a die with its specific shape to create a continuous strand, which is then cut into individual tiles. Dry pressing is the granulated ceramic powder with low moisture content is compressed into a mold with high pressure to form the tile blank. This is good because when it's fired, there's less water content, so it quickens the drying process due to less moisture. And this is where we create our green body. So at this point, you have your green body. And this is a ceramic object that has been shaped but not yet fired. This is the weakest stage of the ceramic manufacturing because the clay is fragile, but it still holds its shape before it's fired and gains its strength back. Green body versus the fired finished tile. A green body, the physical strength is extremely fragile and can be easily broken or reshaped. Composition, it's weakly bound clay particles with water and it still has its organic material in it. Porosity, it's highly porous and it can be reworked by adding water. Appearance is typically has a soft matte finish, and its chemical state is reversible by adding water and can be put back into a workable state. Meanwhile, a fire finish tile, the physical strength is hard and durable and is capable of withstanding handling and functional use. Composition, the particles are fused together through sintering and vitrification with all water and organic materials removed. Porosity, the porosity is reduced during firing and becomes less or non-absorbent, especially with the feldspar closing the porous gaps, depending on the temperature and type of clay and glaze used. Appearance, surface may be matte or glossy depending on the glaze used and what the functionality of the tile is needed. And the chemical state at this point is irreversible. The firing process causes permanent chemical changes that cannot be reversed by adding water, unlike in the green body, where it's still workable. Firing. After the desired shape is acquired, the green body is fired to a moderate temperature, generally between 1700 degrees Fahrenheit and 1900 degrees Fahrenheit. This is to harden the clay and remove impurities, but this is a preliminary fire, not to get the final product. And one of these processes is bisque firing. And during bisque firing, there's water evaporation. The kiln slowly heats to remove all the remaining water by evaporation. If temperatures were to rise too fast, the trapped steam can cause the tile to crack or explode. During this, you get organic burnout, and as the temperature increases, all the organic materials and carbon trapped within the clay are burned off. Proper ventilation is needed to allow these organic materials to escape safely. And sintering, and this is when the clay particles begin to fuse together, giving the tile its initial strength, making the tile become bisqueware, meaning that it's hard, but it's still porous and absorbent, and which is ideal for applying the glaze. This is where glaze firing happens. After bisque firing, the tiles are coated with a glaze and fired a second time at higher temperatures. This stage determines the final properties and appearances of the tile. This is done at a higher temperature. The kiln reaches 1740 degrees Fahrenheit to 2300 degrees Fahrenheit or higher, depending on the clay and the glaze used. This melts the glaze and fully hardens. Vitrification and sintering. At these higher temperatures, clay particles melt together, vitrify, closing the pores and creating a glassy, waterproof state. This step further reduces the porosity and increases the mechanical strength. Glaze melting. The applied glaze melts and adheres to the clay body, forming a smooth, durable, and decorative glass-like coating if it's like a decorative tile, but if it's roofing, sometimes they use more of a matte. Citations.